There are 3 links in the description. First, link to our Slack, check it out and join. Second link is our events. We have a lot of awesome events. And then third, we have a conference soon, check it out. And then last, if you have any questions today, there is a pinned link in live chat, do use it. And yeah, Ilya, please start.
Hi guys, my name is Illia Todor. Thanks for having me. So today I would like you to tell about ingestion and historization in data lake. And there is a picture of plumber who is fixing his pipeline. I think that we have the similar situation, except not is the water is running in our pipeline but data. So who am I? I'm working in IT for 5 years. I started as Android developer, then I moved to data science, and currently I'm data engineer at our staff company Bright Grove. I'm working in HRS group project, and I will tell more in the next slide. Here are some links that where you can reach me out and follow me. I contribute to open source tools that we are using within our company, such as Redash and Amundsen. And also I have my blog, and from time to time I answer on Stack Overflow, and basically I believe in open source. So a few words about the company. Here are some fun facts that you can find in the slides. I just say we provide login experience for corporations. And to dive into some details, what is the concept of login is the service. Basically, we have 3 services that we are proposing to our clients, and we call it as login as a service. So the first one is continuous procurement. So we identify different head destinations where our customers are going to travel. We take care of negotiations with hotels on behalf of our clients. We have built our portfolio of hotels of all the destinations. We propose service year to year by, for the instance, proposing alternative hotels. So let's say people from Amazon are coming to Berlin and they are going to stay in Hilton there. However, next to Hilton, there's a local hotel, Savoy Berlin, and it's actually cheaper with the same quality. So by doing this exercise, we can make significant overall savings year to year to our customers. Also, we have cleanliness and safety protocol that hotels is required to follow for hygiene, and also we give them some label. And Green Stay is about sustainability for reducing footprints for our travelers. The next concept, the next part of the concept is smart booking. Smart booking itself, it's about booking. This is the portal, so people, the travelers, are able to book the hotels, and also we are feeding on our backend all the things that are around travel. So let's say you prefer to have at the same time, at the same place, the car or train. We do not segregate it by our own, but we are using this, we feed such inventory from another portals. And the last one is touchless stay. Essentially, it's about the payment part. We as a company have a bank license. We provide all the payments on behalf of the corporate. Let's imagine the traveler is going to hotel, so he can just check in and check out. He does not need to payments or inform someone. We take care of everything on their behalf. And if, for instance, a traveler uses the minibar, we split the bills for charges and expenses for the company, and the bill that needs to be sent to traveler itself. Also, when you travel internationally, you can claim your taxes back. For individual traveler, there is not much work, but when you have thousands of your travelers, it's too much work. Also, we cover this part. And from our data engineer perspective, smart booking and touchless stay, this is the most interesting part. This is where we collect all of the data. We know what people are booking, what is their behavior, and what can we do to optimize our better portfolio and how to improve our recommendation system. Also, based on payments, we have few cases. We can understand how people, let's say, using minibar, or we can come up to hotels and suggest them to change their price. Let's say €5 less. Then you get some higher chance to get Amazon coming to your place. Or if you would include breakfast, you most likely will be chosen by another corporate. And about the presentation. So firstly, where it comes from, right? So we are updating our existing stack, and we are ditching out our legacy, and we want to move to modern tools. Request itself came from our analytics for further reports and dashboards. So what we have here is a data source, original itself. Then we apply historical changes. We save data to data lake. We proceed this data to data warehouse, and our analytics are happy, and they will be able to build dashboards. What is the historization itself? It's about to track historical changes. What kinds of historical changes? It might be inserts, updates, and deletes of the entity. We are adding two additional fields, valid from and valid to. Before this historization, it's called, if someone of you familiar with SCD, it's slowly changing dimension, type 2. It allows us to jump back to a specific timestamp in the past and read data that was valid at that particular timestamp. It might be useful in further analysis or predictions, or just understand why, let's say, we had some spike in our users. So as example of this, let's say the record Andrew was created on 21, firstly in 1st of January, and then it will be updated to Mark on 3rd of January. So it means that for some time the record was valid as Andrew, then it comes to Mark, and after that Daniel, the record will be Daniel from 5th of January and up to 2099. It means that this record is actual now, as it has the far of the future record as 2099. In general, the architecture looks like this global 4 steps. So we are loading data, then we save it to S3 landing bucket, then we process the data, and we save it to another bucket. This is the big architecture of our solution, and we will walk through it piece by piece. Before we proceed with architecture, I would like to share that we have our infrastructure as a code. We are using CloudFormation templates, and it describes the required resources, and their dependency allows us to run and configure this dependency as a stack. We describe infrastructure in declarative programming way. in YAML files, in YAML templates, and we store these templates in Git along with history. So why would you need it? It gives you ability to quickly turn in the entire infrastructure if, let's say, something went wrong, or someone accidentally deleted all or just one of the components, or you just want to launch this architecture, these components in different regions or in different accounts. So with infrastructure as a code, it will be easy to you. Also, last but not least, it manages correct order of resources. If anyone familiar with Docker Compose, there we need to explicitly add depends on, and in AWS CloudFormation, it manages it by itself. So firstly, we are going to work in for a first part, the global one. And particular one, we will talk about loading data from data source and saving it to our S3 bucket, to our landing S3 bucket using AWS DMS. So DMS stands for Database Migration Service. It helps us migrate database to AWS quickly and securely. It can migrate your data to and from most widely used commercial and open source databases such as Oracle, Microsoft, Postgres, Mongo, DB2. And actually, I believe that if you need migration, your database most likely will be in the list of available ones. General architecture of DMS is the following. So we specified the source database. Source endpoint queries data from source database. After that, a replication task is running on replication instance, and target endpoint saves the data to target database. Worth to mention that we are using a secret manager within the scope, so we don't need to pass our credits explicitly and to keep credits in our repository. So this is a very secure way. We are using under the hood DMS using EC2 instances, and EC2 instance is a virtual server that you rent from AWS. Just a couple of words about this particular one. R5 is instance that this is the next generation of memory optimized instances, the last one, and this is exactly what we need. Since we are working with database, we need RAM optimized instance. Here, I would like you to show the configuration, YAML configuration template for target endpoints, how it looks like as in infrastructure as a code way. So here we choose the database engine. In our case, it's S3, and S3, if someone not familiar, stands for Simple Storage Service. It's just object storage service where we save this our data. And some configuration for S3 settings. We provide bucket name, the prefix one, where we want to save the data, compression type, gzip, and some extra attributes, such as we want to have our data saved in parquet format, and we want to partition it by date. DMS replication task, how it looks like. This is actually where all the magic happens. So you specify which tables or views and the schemas to use for migration, and any other special processing, such as login requirements or error handlings. And literally, this is where, let's say, select star from tables come in for full load, and where we add in where close to select for incremental load. This is configuration of our replication tasks. what you should know before we can create a task, we need to make sure that source endpoint, target endpoint, and replication instance is created. And this is exactly where CFN, CloudFormation, comes in handy, because we don't need to explicitly specify the order of creation. It will be managed exactly by CFN. Here we specify source endpoint, then we specify target endpoint. This is where data will be saved. Replication instance, which will be used for processing the data. And also worth to mention that in documentation, there is no explicit option for login. So we can enable it in UI. You're able to click this login, but in CloudFormation, as it's a pretty modern tool, pretty and young tool, you can do it just within this way. So just some JSON that you can pass to configuration. And table mapping, this is itself, or you can think of table mapping as just select star from table for this configuration, since we don't have any where or another clauses. So we just disassembled the parts about loading data from source and saving it to our landing bucket using DMS. We walked through one specific example. Actually, POC for saving data was successfully launched, and everything was written by our hands. Everything was supported by our hands as well. But unfortunately, there are up to 30 tables in the backlog, and we are just only 3 data engineers. It's obviously that maintaining the flow with our hands is not an option, and understanding comes that something needs to be automated. This is the stage where we are adding metadata storage. Firstly, what is metadata itself, right? So we have data and metadata is data about data. In our particular case, it's metadata might be the following: is table name, schema name, some params that we are going to use for further processing. Firstly, we were using for metadata CSV, but it's not readable and it's not maintainable at all, because of you just confused with all these commas, and it's not like very convenient in terms to repeat, to scale your process. So we realized that we need to go with another tool, another handy tool. This is where DynamoDB comes into play. And what is DynamoDB itself? DynamoDB is fully managed and fully managed document database. Actually, we choose DynamoDB as its fully managed thing. So we are freezing from a headache with provisioning and managing all these resources and underlying configuration. Mostly we use it once a day. We just read from it. If anyone from you familiar with DynamoDB, we just made a scan table once a day. Because of this, it's really cheaper for us to pay for requests and just do our like data engineer development. Because it's always compromised between paying for resources, in this case is DynamoDB, or paying for the developers hours. And in our case, it's significantly cheaper to pay just for requests and just go for further development. I would like you to share with config that we store in DynamoDB. This is example of config that is added to our CI/CD pipeline. So these things are automated. What we have in this config, it's schema name, table name, source and target. We specify from where we want to load data and from where and where to load. we have start and end value for incremental loading to load data with some particular time frames. We select primary key for further merge and timestamp column name for incremental loading. Output, we define output format as sparkey. Firstly, we had CSV. And we have broken datetime columns and decimal with null columns. These columns we need in further processing to beat some issues. And the last ones is Athena table requires, and this is for our ad hoc queries. And if we want our table to be partitioned. So we already walked through this one, through saving and providing metadata from DynamoDB. Let's add some more. I believe that watchful and familiar with AWS folks might have noticed that two different buckets comes here, and you might be questioning, like, why would I need to have architecture like this? Why can't I just skip landing bucket and save everything to vault bucket? And I think you can be like this, yeah. So there is a need. Actually, there is no explicit information in docs. However, when DMS runs the task, it automatically truncates the data in your target endpoint. So it means that all data you already migrated to your bucket will be truncated. So we come up with the following solution. We use SNS. This is simple notification service. It's fully managed pub sub messaging, and pub sub functionality provides for us topics for high through output. And AWS Lambda, it lets us run code without thinking about service or clusters, and we pay only what we use. It means number of requests and duration on when on the time Lambda is executing. So when a file is coming to landing bucket, there will be a topic which Lambda is subscribed for, and Lambda is aware that a new file has came, and just you need to move it to our original vault bucket where we store all the data. So the latest component in first part will be CloudWatch, and CloudWatch is monitoring and observability service. CloudWatch provides you with actionable insights to monitor our application, respond to system-wide performance changes, and optimize resource utilization. CloudWatch also collects monitoring and operational data in form of logs, metrics, and events. And why do we need it, right? So firstly, we use CloudWatch to detect anomalous behavior in our environment. We set alarms, visualize logs and metrics side by side. Obviously, when you don't measure, you can improve anything. So in case we want to improve, firstly, we need to measure. And the last point is we have our product owners, and he has two states, and we don't make him to be angry, and he's happy only in one case when he sees the metrics. This is the UI, how it looks like. This is like dashboards example of our counts, of our statistics that we are gathering, and it's we set up triggers that if anything, if like our average, if our records has significant difference with average count, we will be notified via Zoom. So we have covered the first global part. It's about migration, data migration to the AWS. And the next part will be about historization, how to historize it. In this part, we will be using AWS EMR. EMR stands for Elastic Map Reduce. Basically, it's managed Hadoop. EMR is cloud big data platform for processing vast amounts of data by Spark. In our case, under the hood, it uses EC2 instance as well. And this is convenient and easy for managing, for configuration, coordination, and scaling, because of we are not having our own service, and AWS takes care of provisioning and configuration everything. The next thing is Athena, and Athena is interactive query service that makes it easy us to analyze data that is placed in your S3 using SQL. Athena is serverless, so there is no infrastructure to manage, and we pay only for queries that we are running. This tool is very easy to use. You simply point to your data in AWS S3, you define the schema, and you start querying. Most likely, you will be using it for ad hoc queries. At least this is the way we are using it, just to verify, to make sure the data has came, and to verify something. And the Spark. This is a data processing framework that can quickly perform processing tasks on large data sets. It also distributes data processing tasks across the multiple computers, and this is literally why it's so popular and so fast, because we can parallelize all the tasks across the different nodes. In general, how this way looks like for Spark jobs in EMR cluster. So you provide PySpark script, you place it to S3 bucket, you point your data that is also placed in S3, you start AWS EMR, and you submit Spark job on this EMR cluster, and finally, you will have your process data placed in, let's say, another S3 bucket. This is some example that you might be observing for that we are using for further historization. This is the config, if you remember, from DynamoDB, and here are some particular fields that we are using in this case. For instance, we are using primary key fields that we are passing to historization timestamp column, and Athena required, and do we need to table to be partitioned? This is input params for our PySpark script. I would like you to share the algorithm. It might seem pretty tough, but I will try to explain it as easy as I can. So firstly, we are making initial load. We check if data is already exist in our S3, and let's imagine we are loading it first time. And here are some checks. Do we want it to be partitioned? We want to partition the tables if it's all above 1 gigabyte. So what is less than 1 GB, we want to keep it in single place, but what is more than 1 gigabyte, we partition it in terms of data. So we are not partitioning it because, let's say, table is less than this rule. And so when we do not have, in this case, we are not having timestamp column. It means that we have the row as actual state. So currently it is in actual state. So we just load it, and then we overwrite the metadata in our delta table. In case we want it to have as Athena, to be available from Athena, we are creating Athena DDL. Another branch, I would say same as before, except the record will be having valid from timestamp column because of it has this this particular field. And this is branch when we want our target to be partitioned and timestamp column also exists. The main difference is we are adding partition by date, and we write this data by partitions to our delta lake. In this case, in new branch, we are we have some data in our S3, and we check if we have a primary key and timestamp column in our table. In current branch, we don't have a timestamp column, but there is a primary key. So it means that we need to reload the table every time. And in the opposite side, we are using incremental load. We have primary key, we have timestamp column, and it means that we are in incremental load phase. So do we want target to be partitioned? I remind you that we have partitions all above 1 GB, and in this case, let's say table is less than this number. So we want to just write down the tables, values from and value to, and append all new coming data to existing one. And last case, we have partitions in our table. So this is probably the one difference that we write down the dates. We get today's download date, and it will be used as our partition, and we wrote the existing partitions as well. So this is about the algorithm itself. How do we manage all this stuff? So we are using Airflow. And what is Airflow? This is a platform for development, planning, and monitoring daily workflows. We define tasks and dependency in Python, and then Airflow manages scheduling and executions. So instrumentally, this is pretty simple. We use Python with PyCharm and Git for versioning. Almost, I would say that Airflow, this is most likely, it's similar to Informatica, in case someone is familiar with this tool, but it's more convenient and it's clearer and more flexible. Plus, we have versioning. And docs run on a specific schedule, let's say daily or hourly, or it can be run based on external event trigger. In our case, we have some trigger when file comes into a specific bucket, specific prefix. We are under the hood. We are using Airflow on AWS. It's called MVAA, Amazon Managed Workflow for Apache Airflow, and this is the benefits of it, that you can use Airflow and Python to create workflow without managing the underlying infrastructure, and for scalability, availability, and security. So again, AWS takes care of everything. So you just develop your docs. In further slide, I would like you to show our doc. But before, here the components that will be taking part in our doc. So it's DMS, Database Migration Service. It's DynamoDB metadata. It's EMR cluster, Historization application, and Historization publishing metrics to CloudWatch. This is how our doc looks like. and let's start one by one. So firstly, we are pulling data from DynamoDB. Then based on that, we run DMS tasks. We publish the metrics to CloudWatch, and in parallel, we are running our EMR cluster. In this case, we are copying all required jars to our local Ivy artifact repository. Then we add the setup steps for convenience login, and we run historization step and historization metric steps on EMR cluster. And once it's finished, it automatically turns off the cluster. So in this case, we might we start a cluster and a historization process right after all up to 50 tables have been finished. And what does it literally mean? It might bring us to the following possible situation. And as you can see, on y-axis we have tags, and on x-axis we have time. So in this case, the tables might be skewed, and let's imagine that we have 50 tables, and one of them is huge, like really huge. All of them is small, but one of them is huge. And it means that in this case, we need to wait all tables to be finished before we start move on to process historization process. So we somehow realize how to improve it. So in this case, you can see that we are adding, actually we add trigger rule one success to our start cluster tasks, and also we add the dependency on our historization step. So right after DMS task, let's imagine table A DMS task will be finished. Automatically, it will triggers cluster to launch. Cluster launch up to 10 minutes, so it takes some time as well. And meanwhile, cluster is launching. I believe that another tables will be finished till this time. And we add dependency to historization step because of we do not want to process to start historization process over the table that wasn't finished before, that wasn't finished completely on DMS part. So I mean that right after the first tasks successfully finished DMS part, database migration, we are able to start historization process for this one. And the part about monitoring and alerting, as you might know, Murphy's law stands for anything that can go wrong or will go wrong. But at least we want to be prepared, and we would like to get to know about the incidents before our data users will discover the issue. So how do we handle it? We add the following DAG config. These args will be passed to each operator, and if tasks are fallen, now we have some retry policy, and we, in case if retry won't help, we will be having email on our email, and we will be notified. So we defined retry policy as 3, and retry delay 3 minutes. So if our first launch fails, we will be having 3 retries in time delta with 3 minutes. And if it's still failing, we will get alert email and alert in our Zoom channel. So this is the way how to prepare ourselves to the unexpected behavior. I would like you to share the points to improve, how we optimize the costs and met some issues. In this case, we got the following error that cluster was terminated with error. Master node was terminated due to not enough capacity in the spot instance pool. Before I proceed with solution, I would like to share with you what is spot instances itself. So AWS offers us spot instances that lets to run unused EC2 resources in AWS cloud. We can save up to 80% compared to on-demand. However, there is some caveat, and I want to highlight that you cannot run, let's say, your production database on spot instance because it might be terminated just within 2 minutes because someone will be paying for the instance a bit more. But spot instances can be used for to run a variety of resilient and flexible, or let's say stateless application, such as big data processing, especially in our case. And what means this issue? It means that demand is over capacity. It means that there is not enough capacity to fulfill our demands. The solution for it, we can use AWS EC2 fleet. When we start a cluster, we can specify some EC2 fleet configuration. And with this configuration, EMR prepares instances until the goals are met. So we can specify up to 5 different EC2 instance types that EMR will use to meet our goals. And also we can specify multiple availability zone. Let's say in Frankfurt, there is not enough such EC2 computers, but in Frankfurt, there is some instances that might be used. So with this, we can use all the instances across the few availability zones and search for this to fulfill until you fulfill your goals. And you might want to say that Ilya just comes here to boast some success story, solution. Everything looks good, everything is smooth, like in Wonderland. But I wish it went smoothly. And I would like to share how we were jumping on AWS Rake and how to handle every single only in this professional Rake. So the first one is data type issues with time millis. Int 32 cannot be converted to millis because I bet you can guess, because it's not implemented. It's not implemented, Carl, in 2021. So we just proceed with it. Another issue was with inadequate date. We select min and max date from our table. So first one is 6th year of our era. And how I imagine it to myself, Asterix and Obelix bits of the attacks from Romans, and we already have our DB2 running. And max date, yeah? It's not clear in what form and where we will exist in this cyberpunk 2518, but it seems that DB2 still successfully plans to store the data. And the last issue, it was with float, with decimal. Actually, Spark along with Sparky, the above mentioned data format just loses records for some reason. And solution for it, yeah, just to string. In any incomprehensible situation, convert data to string, and here we go. Another one, we had about 50 tables worked fine, but one of them needs a longer timeout for some reason. It is pretty unclear why it is, but with adding extra attributes that we got the advice from AWS support, it solved the issue. Before I will tell you the next story, I would like you to remind replication task part, and this is where our migration takes place, right? So about 50 tables are all good, and one of them is not loading. There is no explicit understanding what went wrong, because the logs are like, sorry guys, we just failed, we cannot proceed. So we wrote a request to AWS, and it turns out that issue lays in schema name. Let's say we have schema, my scheme. We need to calculate the length of the name. As we are Python developers, we don't want to calculate it but by our own. We just use the length of string. And it turns out that this is known issue when using DB2 as source with schema name having underscore and less than 8 character with specific selection rule. And we were like, what? How does it possible? Okay, let it be. And what is the solution? They accept that they claim that this is well-known issue, unfortunately, and they're in process to update the documentation due to this limitation. And they advise us to change rule action from include to explicit. So by changing these rules, it works finally. So here some few decent struggles from my points of view that I've shared to you. Of course, it was a bit more, but this is one like the good ones to share with you. Further, I would like to share with you further work what we are aiming to. So at this moment, we are manually loading data from our Delta Lake to DVH. And in further plans, in nearest plan, we want this job to be automated. So every time when data came to Delta Lake, we want to automatically move it to DVH for further reports. This is our further work, like nearest work. And achievement, what have we done eventually, right? We have built ETL process for full incremental load data from data source to data lake. We automated and auto-scaled process. About 70 tables are running day by day. We have just only one entry point by adding new table to a process. All other steps are catching up and reusing this metadata. Actually, now if request comes from analytics for a new table, so this table needs to be available in Delta Lake. Our product owner, the one I shared with you guys, he can add the table to our config JSON. He pushes the data, pushes the code to our repository, and data will be available right in the next morning. So we have automated it, even that our product owner is able to, let's say, load the data from our data users. We enabled process monitoring and alarming on data and process issues. And our data is stored in effective way. Why I say in effective way? Because we started with a CSV, but we could manage to tackle this issue with Sparky, and now it's in more appropriate format. And also data is available via Asina and Redash with another different tool. Redash is BI tool. And yeah, that's it. the learning point to you guys, I believe that I shared and demonstrated our case how to migrate data using AWS service. And I hope that my solution can be adapted to other clouds as well, such as Azure or Google Clouds, or you can just copy it to AWS. It would be nice as well. So it's time for a question. But before I finish my story, I'm really asking you to don't hesitate and give a feedback. So you can just copy this QR code, and I would like to improve myself, and you really can help me to understand and beat my weakness in terms of presentation. I will read every single response from you guys, so be sure your voice matters. Thank you.
Yeah, thanks for the presentation. If you can send me the link to the survey, I'll include this in description. And so if somebody watches the token replay, they can just click and give you the feedback.
Sure.
We don't have questions, and I just want to remind you, if you want to ask a question, there is a pinned link in live chat. Just click on this. And I have a question. So you showed this complex algorithm with for historization with this,
I can go to that one.
Yeah. So I was wondering if there is a written version of this algorithm somewhere, because it's like just a lot to unpack, and if maybe some written version somewhere that we can just go through, because like to me, I understood some parts, but yeah, it was a bit tough because it's just a lot of things.
Yeah, so actually we have the same graph in our Confluence, but probably since we were developing this algorithm, we don't need like a text version of it. But maybe if you don't like understand, I believe it's tough to understand. Maybe you can ask something right now, and I can make some light on the component.
No, I think it was just like overall for me, it was difficult to follow, and then at some point I got lost. And,
at this branching.
Yeah, let's not waste time, and I'll just offline try to go through this and understand. And also, you mentioned that you needed to use two S3 buckets. So in the first one, the data was truncated. That's why you needed to use like SNS and Lambda. So what does it mean to be truncated? What exactly is it?
So before DMS starts, it deletes every data in bucket.
Okay. So it basically just everything that is there in the bucket, it removes.
Yeah, it removes by default, and you cannot change this behavior.
Okay. Is it documented?
Not really. Because I just I remember that I go to work like some few days in a row, and I noticed that in the evening there is the data, but in the morning of the next day there is no data. The data that was loading the previous day. So I was like very curious, and I don't understand how it comes. So like I wrote the support ticket to AWS support, and they mentioned that it truncates the data. And we wanted to proceed with actually two formats, just in case, with CSV and Parquet. And I asked them if it's possible to have like two different formats in the same bucket. So they answered to me that it's not possible because DMS removes everything before it starts the job.
Yeah,
it's not very convenient, but it's handleable.
Okay, so that's why the moment the file is there, you copy it in a safe S3 bucket.
Yes.
So it's not deleted. Okay. Yeah, I don't have any questions. So there is a comment that thank you for your presentation. It was very informative, and I agree. And Ekaterina is asking if the video will be available. It will be, so it will stay in the channel, so you can watch it later. And Ilya, maybe if you can share the slides with me, upload to
Yeah,
SlideShare.
sure.
Upload to SlideShare or something like this, and then I'll just include a link.
Yeah, guys, you will be able to walk through the slides by your own, because I believe there's some tricky parts that you want to remind and go by your own to read everything, not just hear my voice.
Yeah, so the algorithm was a bit complex, so it definitely needs to, like, at least for me, I need to.
I really tried to simplify it, but I don't know the way how to do this.
Yeah, it's probably just the way it is. Okay, I think we have a question. Yeah, so there is a question. Let me just share my screen.
Let me stop sharing. Yeah.
So yeah, maybe you can read it out loud so I don't stress my voice.
This is a really great question about changing the schema. At this moment of time, we are not struggling with this request, as we are using already very very old tool. We are using DB2 schemas that is quite popular in our company, and there is no, I think, no new tables. But we are migrating the popular one, the existing one. So this is a really good question, how to take care in case if will be changed sometime. But at this moment of time, we just we don't face such request.
Okay, thank you. Yeah, so maybe let's wait for 1 minute before wrapping it up. Maybe somebody wants to ask another question.
Yeah,
Just
sure.
a quick one. So you said you sent a alert to Zoom.
Yes.
You
We are
Zoom like a chat, like
like a Slack. Yeah. We are using primary Zoom in our company. So I was wondering as well when I firstly heard it. But yeah, there are also API as Slack has. So we just configured our callback in case the task is failing, and we configured our appropriate channel for this kind of notifications.
Do you know Zoom can do this?
I thought as well that Zoom is aiming only for video calls.
No, this is how we typically use it.
Yeah.
Okay, thanks a lot for your presentation, and thanks everyone for watching. And I think that's it. We can,
Yes, thank you for having me.
Wrap it up. Yeah, thanks. Yeah, please send me the slides.
I will
put them.
yeah, I will share. Thank you.
Well, good evening and goodbye.